All right, hey guys, let's go over multiplying numbers in scientific notation. This is actually super easy. I already got a problem written out here. Let's take a look at it. So here's what we got going on here. We got 8 times 10 to the negative fifth times 2 times 10 to the eighth. And really the trick here is, you can just type these into a calculator that works out scientific notation. That's always great if you know how to use the calculator and you have a calculator available to you. But really, this is pretty simple, and it builds upon some properties that you should know already from algebra or pre-algebra, which is utilizing the product of powers property. And it makes this pretty quick and easy. So let's take a look at it, kind of working it out. I wouldn't say by hand, but using our shortcuts and our properties. Okay, so one good thing to understand here is that everything is just being multiplied. Okay, there's really no mixture in operations. We have these powers here, but really everything's being multiplied, right? We got times here, we got times here, and we got times here. So really we could utilize the commutative property here, and we could just reorganize these. So even though I do a lot of these steps in my head, I'm going to go ahead and write it down here just to show you what's going on in my mind, right? Until you get really good at these. So let's take this and rearrange it. Let's take our 8 times 2 first. And then we'll put our times 10 to the negative fifth times 10 to the eighth at the end. So if we look at it this way, right, we can use the commutative property here, and we can rearrange these. We can take our 8 times 2, right, and then we can use our product of powers property here. And then we'll just carry down that we still got that times sign, right? So let's go ahead and take our 8 times 2, and that gives us 16. That's pretty easy, right? And then we won't use this times sign yet. We'll just bring it down. And then we'll go ahead and use our power times a power property as long as the bases are the same, right? We have a power times a power, and the bases are the same, so we can pass that common base along, and we can actually add the exponents, right? That's our shortcut. So negative 5 plus 8, that's going to give us a positive 3 exponent. And there is a good answer. It's just not fully in scientific notation, right? This is right, though. 16 times 10 to the third is the correct answer. It's just our leading digit here is not less than 10 and also greater than 1 to be in true scientific notation. So let's go ahead and fix that. So a little rule here to go by, acronym, whatever you want to call it, is the LARS principle. So this means if you have a number written in scientific notation, okay, and this leading number, if you take the decimal point and move it to the left, right, L stands for left, you add to the exponent, however many times you moved your decimal point, okay? If you move the decimal point to the right, okay, R stands for right, you subtract from the exponent. Okay, so LARS means if you move the decimal point left, you add. If you move it right, you subtract. So we need to move the decimal point one spot to the left here to get that number to be less than 10 and greater than 1. So we moved it left, which means we add to the exponent however many times we moved our decimal point. So we moved it left once, so we add 1 to the exponent. So we're going to end up getting 1.6 times 10 to the fourth here. Right? Sorry, I need to scoot my screen up. So we moved it left once, okay? Left once, so we add however many times we move the decimal point to that exponent. So we moved it left once, we got to add once. Okay, so 1.6 times 10 to the fourth is actually the exact same answer as 16 times 10 to the third. It's just this answer is truly in scientific notation. So that's one we'll leave for our final answer. Okay, let's try another one. Let's take a look at what we got here. Okay, so we're going to use the same concept. All right, so we got a number in scientific notation times another number in scientific notation. Now, I don't have a time sign there, but you just need to understand, right, that anytime you have two parentheses next to each other with nothing shown in between, it automatically means that there's a times sign there, okay? So we got 3.6 times 10 to the negative fourth times 7.5 times 10 to the negative ninth. I could just plug that into a calculator, but we could also utilize some properties here we should already know, okay? So let's utilize the commutative property here. I'm going to rearrange. Okay, I'm going to take 3.6 times 7.5. Since everything's being multiplied here, right, I can rearrange times, and then I'm going to put my multiplication of my powers next to each other because we should be realizing that we can use our property of powers exponent there, right? So let's go ahead and multiply those. We'll carry that times sign down, and we'll go ahead and use our product of powers property there, right? So yes, I have a calculator here with me. I'm going to take 3.6 times 7.5, and that's going to give me 27, okay, times, and then let's use our power times a power property here. As long as the bases are the same, I can pass that common base along and just add the exponents, right? So that's going to give me a -4 plus a -9, which is going to give me a -13. And that's a good answer. Okay, it's not in true scientific notation form, so we need to utilize our left add, right subtract rule. Okay, there's our decimal point, the number 27. We need it to go here to get us a number less than 10 and greater than 1. Okay, so we moved it left once, so we got to add once to our exponent. Okay, so we moved it left once, so we need to add 1. So -13 plus 1 actually gives us to the -12. And there's a good final answer written in scientific notation. There we go. So I hope that helps. That's multiplying numbers written in scientific notation.